We'll wait for a couple of minutes for Jeff and for to join.
I'm here. This is Jeff.
Oh, hi, Jeff.
And this is Ian. I just dialed in.
Okay, hi, Ian. What happened? So we can get started now. In the room here I have Trevor, Ergin, Nina, Rilling, Divakar, Shaoling, and Hua. And on the call I have Huni, Ian, Nansu, Ron, and Wei. Have I missed anybody? Jeff.
Yeah, that's Jeff.
Jeff is gone. He's not on the web thing yet.
Not yet. Getting there.
Okay. Did I miss anybody? Alejandra and Philippe are at a conference and won't be calling in. And also for next week, we'll be canceling the meeting since most of us are going to be at ENIA. And then we'll resume the week after. So on the agenda, we have updates on action items, and then Shaoling will present the evaluation that she's done using DataMed and the benchmark data set that was generated. We also have some updates about the link out, for which we had a meeting, and we'll talk about inclusion of repositories into DataMed, which is pretty much the ingestion plan that we have. I also want to talk briefly about the DataMed version 1.5 release that we are planning for November 22nd, and if time permits, then we can have updates from all the team members. So for action items, we need one of the action items that we've had is to have a help and a FAQ page. Nina has generated an outline for putting in information which is available on the BioCADI CDT folder. I've provided the link multiple number of times earlier, so I didn't want to repeat that, but please do start adding material here as soon as possible. And then Jeff was working with Claudio to have a robust server to host the BioCADI. Jeff, do you have any other updates on that?
So I saw we have the queries that the one query that that Ruling provided us, but I wanted to actually go over that with Ruling. So if we can stay on the call a little later today.
Okay. Or I think this room they have a meeting.
Okay. So I mean we can call on a separate.
Yeah. We'll probably call in again, and then you can talk about it. Okay. And have you had any other feedback on the video, Jeff?
Nope.
So if anybody has feedback about the video, if you could provide that, that would be great, because I think one of the things that we want to do is to have the feedback, the video available. Would it be possible to have it available for the BD2K all hands?
Yeah. So he's working on our meeting next week, and then he's almost done with all that, and then he can shift back to the video.
Okay.
Maybe we ought to set a hard date for ending the comment period.
Well, if I don't, I would say then by this Thursday.
By Friday?
Yeah,
Thursday?
Friday.
Yeah? Uh-huh.
Yeah, Thursday or Friday.
Okay, why don't you make it close of business, make it Pacific time on Thursday.
And also with the pilot project integration, the plan was to get in touch with both the pilot project leaders to get some additional information from them. And once we have that information on hand, then we go back to discussing if and how we want to integrate this part into DataMed. So Xiaoling will talk about the evaluation of DataMed on benchmark datasets.
So I'll update what we have done on the DataMed evaluation using the benchmark dataset. So I think from this year January, we start to work on the benchmark dataset. That's before the version 0.5, and we store all the metadata at the elective search endpoint at that time, use it for create the benchmark dataset. And so the benchmark dataset includes 794,000 datasets, and it includes 20 repositories. And so here's the example, so how the benchmark dataset looks like. We assign each one a document number ID. We have a title, which is extracted from the metadata. We have a repository field, indicate which repository is from. And we keep all the metadata in that dataset into the metadata field. We have 15 test queries. I believe it's from the BioCAD user cases, generally from that. So here is an example of the query. Like the query in the natural format is find all data type related to information, blah, blah. We manually extract the keywords from this query and make a keyword query version. We also generate an expanding query version for this query. So the expanding query version are generated using the terminology server. Then we manually look up and combine the synonyms together and construct the expanding query. So for each query, we have two versions, a keyword version and expanding version. So here lists all the 15 queries we will use for test. 15. So then we will generate the gold standard results. So for each query, we query in two versions, keyword version, expansion versions in four different search engines, Lucene, Indra, Carrier, and Semantic Vectors. And then for each search engine, for the top 300 results are extracted. And we combine them together and delete the duplicate one. Then maximum 2,400 for each query will be annotated. We have two annotators for annotate on this combining this. So here is the gold standard for the annotation result. We annotate as relevant, partial relevant, and not relevant. So this one will be used as the gold standard we use to evaluate how the search result. So We use the track evaluation tool to compare the search, to evaluate the search results. So track evaluation tool is a standard tool used by the track community for evaluation the information retrieval. So given a gold standard judge results and a result generated from the search engine, this tool will give some metrics that you can use to compare. So these are the commonly used metrics that people use to compare the performance. One is INF-AP is inflow average precision. One is INF-NDCG, which is inflow normalized discounting cumulate gain, and also the precision at the end retrieval and the precision recall precision average at end recall. So these four metrics the track evaluation tool can generate automatically. So here I index the benchmark into the elective search and search all fields using the default TF-IDF algorithm and retrieve the first 300 records and use the track evaluation tool to get the numbers. So here lists the individual query results and also the result combine all the queries. So the query 9 get the best result, and query 1 and query 12. Query 12 has a worse result. And the combination of all the queries of the INF-AP is about 0.04, and the INF-NDCG is about 0.056. And I compare this result with the track 2014 DDS check, which is the clinical decision support check, which includes 30 topics. The top one of the results, INF-AP 0.06, and the NDCG is 0.26. And the top 10 is 0.049, and the INF-NDCG is 0.19. So compared to their results, I think the result from the elective search is fine. So I also compare the elective search result with the different search engines that we using the basic query and the expanding query. So for both cases, Lucene achieved the best. It's better than the elective search.
So the question there is, since Elasticsearch uses Lucene, what were the options that were used?
Yeah, so here for elective search, we just use the search on the query with the default one. We didn't set any parameters.
Yeah, what's the difference between Elasticsearch and
No, Elasticsearch uses a different ranking metric than the Lucene. It's in the documentation.
Yes.
It is in their documentation, like what is their formula and what is Lucene's formula.
Oh, I thought they both.
Okay, because they have different ranking.
Different ranking algorithms and calculation.
Yeah.
It seems to me that, and I don't fully understand. I can't say I'm an expert in this, but the numbers are not very far off.
Right. Yeah, there's not much to choose between these.
No, but it would be interesting to know which one was used in Lucene, because in Elasticsearch you can actually configure, the ranking algorithm. So.
Mm-hmm.
So we try to look at the specific individual fields and to see how we can construct a query based on specific fields, and then hope we can improve the search performance. So here I look into the fields in the benchmark data set, because at that time many of the repositories are not mapped to that model, so there are lots of unique fields. So the total is 187 unique fields. So I run the search on each field individually. 11 fields is in integer or date format, so cannot be searched using terms. So 68 fields does not return results. It's like the home page, the date system, the rank. This kind of fields does not return results. So the 108 fields return results. So here I have some preliminary results that I try different combination of the search query. So I search the query only on the title field, and it gets like the INFAP 0.02, and only on the description I get 0.02, and I search the title and description fields only, and it's better than search only the title description. And then I tweak like get the title a lower booster value, and it's better than the title and description treat equally. So there are lots of different ways we can try to see how if we can make a better result. So right now,
when you're searching specific fields, and you're taking the queries that you're running, are you interpreting those queries and saying the best way to execute this query is to search for this in this field, this in this other field, and this, and that means some analysis of the meaning of the query. And so, for example, we have a field which is a chemical entity, all right? So we've got a drug name. Then the sensible field to be searching for that in is, might be the chemical entity, for as a rough and ready example. But it sounds like the approach that you're taking here is just to put the whole query against each of these fields individually. Is that right?
Yes.
Okay.
For that purpose, we need to use the NLP server to recognize the...
Yeah, we don't have different fields for different types of entities, but we do have, say, for title, description, and description can contain chemicals, genes, proteins, all those different.
But we have those in Elasticsearch at some point. Maybe not what you're searching. Right? I mean, thinking how PDB, looking at how PDB is indexed.
Yeah, so some of the material entity fields have chemical, and then also, for example, links has proteins.
Yes.
But are those not being searched, Hua?
They are being searched right now. But right now, to search that, we have to do NLP on both sides. So you on the metadata texture field like title, description, we have to run NLP, recognize all those gene names, chemical names, and go through the index them as chemicals entities. Then on the query side, we have to pass the query using NLP to recognize those different type of entities. Then we can put in more weight, say, on some kind of field with chemical matching or gene matching. Right now, what we have is on the NLP part, we didn't pass all the metadata for each data set yet. And what we did is NLP on the query side. Giving the query will recognize maybe gene names, chemical names, and we use the recognized name to do a query expansion. We find the synonyms for that gene. And instead of searching the original gene name, we now may search 3 different gene names. But now we're still against the texture words in the description, in the title, searching those names.
Okay.
Yeah, we are working on that part. Right now, the performance of the NLP to recognize gene, chemicals, still not ideal. We tried a couple of tools.
And just to understand, when all shows up on here, isn't that the same as what we were looking at on the previous one? Is that right? Is that for comparison purposes?
Right. The number is the same. Yes.
Yeah. Okay.
So if you're working on this,
the number just we saw so many numbers. I can't remember which.
So here we will try to.
Overall information retrieval, the performance is pretty low. I mean, right now it's still kind of very challenging task to try to find the relevant ones from large amount of pool, the very big pool of samples. So.
Yeah. So here's our next steps. We will try to explore more and to see if we can conduct a strategy of the query to use for the search engine in DataMed. And this can also use as the baseline for the challenging, NLP challenging, to evaluate the participation results. Yeah. So that's it.
Yeah, so I think there's quite a lot of work to do on the improving the performance-wise. Recently, we actually just fixed the bug we have about query extension, finding synonyms. And previously, when we type breast cancer, we will find some gene names which related to breast cancer. But that's sort of completely wrong. Actually, now we recently just use different ways to recognize those disease names and make more careful about the query extension. So still a lot of work. We also, maybe next time we can show some work we did for the synonym expansion. Like that part I also actually need a careful evaluation. Otherwise, we're getting a lot of synonyms return a lot of false positive results.
So also one of the things that you want to keep in mind here is this is done with material that was frozen back in June, and actually the current material is slightly different and also normalized differently, because there's a quite, I mean, between DATS 1 and DATS 2.1, the models are quite different from each other.
Ruling, could you summarize in just a couple of sentences what you think you've learned from this evaluation thus far, and then what needs to be done further?
So I can summarize that. So I think
okay.
What we learned from this evaluation is right now using the default Elasticsearch engine, we can reach kind of typical performance as other people reported in like a similar information retrieval challenge like a track. So from that perspective, we think using Elasticsearch can reach like a reasonable performance. But to further improve it, there's still a lot of work to do. Carefully selecting synonyms, adding more NLP processing capability to recognize genes, chemicals more accurately, like Ian suggested, and how we can add those into the searching algorithm to further improve the performance. And we also going to try out different, maybe a set of other algorithms, and to see how we can further improve the performance for the overall searching.
So to take as an example, when you're talking about improving the performance, and so you have an example here, the top bullet, you're trying the different similarity algorithms and to try those out in Elasticsearch. Mm-hmm. So to some extent, you've already explored those algorithms. If one goes back to the slide and looking
you go back to we already tried several different.
Let me get my question out. Mm-hmm. The question is this. I mean, if you go back to the slide that shows the different queries.
Go back.
Right. So between those five, we're seeing a range from 4.3 to 4.9% precision, right?
This is not exactly the precision. This is inferred, right?
Right.
Average precision. Yeah. It's
I mean, one way or another, it's a precision measure, but we're not seeing a huge difference. I mean, if you try out these different algorithms and you try them out in Elasticsearch, one's not going to expect to see much more of an improvement of precision than you see here, right?
That's correct. That's correct. Probably you try all different algorithm may not see very big improvement. Travel, you have something to say?
Yeah, no, I'd agree with that. But
Yeah.
to me, the most fruitful direction to pursue would be the expansion of genes with
Yeah.
synonyms.
Synonyms, yeah.
We know that
Exactly.
works from other information retrieval evaluations.
Mhm.
So,
Mhm. Yeah, I agree with that too. But since those implementation in Elasticsearch, that's very easy to try, so we thought, why not just
Yeah.
try it to see?
Well, the other question, I mean, and I'll make some effort to understand the exact nuance of this as a measure of precision, but what it's saying is we're talking about less than 5% of what we get back is relevant, but you're doing this against the first 300 hits.
Yeah,
what does the precision look like with few number of hits?
Yeah. So I was just talking to Xiaoling. What we're missing here, for example, position at 50, the top 50. So that's what we have over here. If you see last column is position at 10. So if you look at this one, first query, first 10 returned results, 4 of them are correct, are relevant, right?
Mm-hmm.
Are you choosing partial relevant as relevant too, or this is pure
These are
relevant?
returned by the track evaluation tool.
But because we have 3 categories: relevant, partial relevant, and non-relevant. Are you treating partial
I
relevant
think the
as
track
relevant too?
evaluation tool take care of the relevance.
Okay,
Yeah.
but double check it. I'm trying to make sure this 4 out of 10 is like a definite relevant, or it also include partial relevant.
Okay.
So if you include partial relevant, then that position could be even higher. Yeah.
Okay, so this is the PowerPoint version of this, and it's good to have this summary. There's probably only so much depth we can go into it here. How are these results available somewhere?
No, this is the first time we showed over here, right? Yeah, we
Yeah.
can make it available somewhere online.
Okay.
Yeah. Yeah, I think it's to see the position at 10. That's actually much more, easier to interpret instead of that infer the average position. Although it's like a common measurement for information retrieval challenge task, but it's a little bit difficult to.
I think inferred average precision also takes, I mean, when you go into all, right, it takes into account all the queries, correct?
takes into account all of the relevance.
All of the relevance.
Yeah, all of the
But sometimes also keep in mind, I mean, if it's relevant, even based on human judgment, the agreement may not that high. Two annotators may not agree with each other if this one is relevant or irrelevant.
In fact, when we were doing the benchmarking, we had a lot of situations where the 2 annotators annotated the same data, but one annotator thought it was relevant and the other one thought it was partially relevant.
Right.
And there are also situations of duplicates within the system where the annotator probably annotated one day as partially relevant and the next day thought it was, relevant.
I think that's very typical.
Okay,
And
so also, where is that data set? That data set would be good to have available also.
The data set off?
Benchmark?
Yeah, we'll release that after the challenge is over.
That's
Is
the
that
data
what
set
you-
we use for challenge. Is that what you're asking, Ian?
Well, what you're saying is some annotators looked at it and marked them as relevant, and others marked them as not relevant.
Right.
But the data set that I'm talking about is where are the results of that annotation. So we can.
Okay. So I see what you're asking is actually the original annotation by individual annotators, right? And it showed agreement, disagreement between those two. We should have
That's
that.
the data.
Yeah,
I mean, we're eating our own dog food here, right?
Yeah, I know. But what I'm saying is, go ahead.
What we're talking about is making data sets available and letting people find data sets. What I'm asking is the raw data set that you're running these off, let's make sure that data sets are available.
Yeah, we have individual annotated data set. Then that's actually going through the training process. I mean, first they may not agree with each other very much. Then we go through couple of session training to reach consent. Then when we finally annotate the benchmark data set, we don't have like a lot of overlap between two annotate. We still have some to calculate agreement.
I'm talking about the end. I'm talking about the end point, right? The end data set that you're then running this on, from which you.
The benchmark data set. Then that one is what we use for the challenge. It's definitely going to be available.
It's available actually. If you, in fact, everybody who's on the BioCaddy team. No, you don't need to sign up. You already have access to that.
Yeah, we got to hold this little bit until the challenge because we have reserved I don't know, maybe 10 queries for testing. So we don't want to release this annotated.
15 queries.
Well, you may not want to release it publicly, but I think someone.
To us.
Yeah,
if you're sharing these data with us, please make
that's
make
fine.
the reference data set available to us.
Oh,
what
that's
we've
fine.
got here is a calculation of precision, for example, that is based on somebody's judgment about whether something is relevant or not relevant. I'm just saying we need to see the data set that says where somebody made the call of whether it's relevant or not relevant. And the data set that then you are then running this against.
This benchmark data set can be open to the BioCaddy team. I mean, you guys can all have access right away. We sort of trying to hide it from the challenger team. So
and you can make
but it can be put behind, the BioCaddy membership, wall, if you will.
So Ron, all the challenge people have been made members of BioCaddy team so that they can access the material that we have provided for them.
Okay, let me rephrase it.
Only what we can do is these are not very big, large data, so we can send it out to you and Ian and anybody else that's specifically interested, because I know, for example, Wei is participating in the challenge just to go through the challenge.
But so we have it on Google or somewhere, right?
All right. You need to let us know where it is so that if any of our colleagues
with a password protection, so let Ian and Ron have access.
They do have access.
Oh, they do have access?
You already do have access. Let me send you the link to the website from where you can actually get it.
Okay.
Everybody who's a member of the BioCaddy team has access by default.
Oh, okay.
Okay.
This is Wei Wei. I didn't try to access the data.
I'm sorry?
Okay.
I never tried to access the data.
That's fine, because you participate in the challenge. You shouldn't.
No cheating on.
Yeah, although I'm not running for money. But
no, it just needs to be available in case one of our colleagues asks us.
From your data set.
Anu will send you the link. I know it's somewhere online. Yeah.
Okay. Let's make that an action item.
Okay. What's next?
So we just wanted to provide some updates with regard to the link out. We had a meeting. Let's go here. We had a meeting. Ian and Xiaoling and we had a meeting with Kathy Kwan on Friday. And so it was decided that we would try the link out from PubMed as a first trial. And so Kathy yesterday sent us provider ID and the FTP site, and now our action item is that we will provide sample data for her to take a look at and once we get the green signal from her, then we will actually provide the complete data. So these are the databases that are available for linking from using the link out program. So right now we have only,
So
we are
let's
doing only
clarify for
PubMed.
people, Anu, let's clarify for people what that means. That means that if you're in these databases, there's the potential for a link to DataMed. So relating that to the previous slide, what that means is the test case is to say if you can see a publication in PubMed, there's potentially a link from PubMed to DataMed to the data sets that are indexed by DataMed, where that publication is the, where those data sets have been, and the association is that it is the primary publication from which those data sets, or those are the primary data sets for that publication. So.
Yeah, I mean that's the one that's an initial relationship, but I mean potentially you could also do.
We could do all sorts of things.
Yeah, you could do like if a paper sort of used a bunch of data sets, so what are the data sets that paper used, or similar data sets as to the ones in that paper. I mean, so there are ways that can be expanded then.
Yeah,
we
we
didn't want to
talked
get
a little bit
complicated
about that. And Kathy wasn't very enthusiastic about doing the similar data sets. Or
Nor was
even, yeah, Kathy.
That could be on our but that could be on our landing page, right? So it's not on PubMed. So if it's a primary publication of dataset X, so the question is where, is the link
I have no way of
does it go directly to that data set, or does it go to a DataMed landing page first?
I have no way of putting this subtly, Jeff. I think we need to respect here that when we're doing this, we're dumping something in somebody else's sandbox, and we should tread carefully when we're doing so.
No, I've done link out before.
With the discussion with Kathy, I think we were, having the right degree of caution about that. But there's potential here, is what I think, Anu. I mean, and I highlighted the possibility, for example, looking at protein. Why wouldn't you be linking into the protein structure from the protein page?
Right.
Right.
Yeah. No. So I mean, PubMed, they for our other projects have requested that we go to a landing page on our site because of the number of link outs that we provide for certain entities.
Right.
So
for
yeah,
example,
we are not so. They will still go to a landing.
Go ahead, Anu.
No, so they will still go to a landing page. In fact, there was one publication that we came across by chance that Xiaoling had prepared, where one paper had about 49 structures that it was describing. So there were 49 different records in PDB, which were all for which this was a primary publication. So in such a situation, you cannot go to the data set directly. So we essentially would have to go to a search page, which lists all those 49 different records.
Right, yeah, because Linkout doesn't want you to have 49 Linkout entries because it breaks their system.
Exactly. Yeah.
Right. And we showed that example, and basically what it went to was, as Anu said, the search page. The only thing we suggested changing about it was that it actually did the search explicitly in the PubMed ID field.
Yeah.
Right? I mean, this is a perfect example. In fact, we got, on that search, we got 100% precision and 100% recall. It was perfect. But it was fortuitous that was the case.
And if one adds a flag to the link out entry, that basically says it comes from link out, then you could potentially add, the other boxes on the side that are like related data sets or things of that nature to sort of customize it for, someone coming from link out, if you wanted to provide the, similar data sets and other features.
In the search page, because we provide similar data sets.
No, I'm just saying if there are any special link out features, because you provide PubMed with a static URL. So if you add, external equals link out, saying that this is coming from link out URL, then on the UI side, you could always customize it a bit.
Okay.
So, I mean, that's just something to think about. That's something that we've done in other projects, is to customize the link out pages. So.
Okay.
But the one thing we've never done with this functionality is got user feedback on what would be useful. And so I think we need to be, trying this out and getting some user feedback on it about what would and would not be useful.
Okay. So with the inclusion or the repository ingestion plan that we currently have, we are actually doing pretty well. One of the things that we have been working with all the 3 sites have been doing, so I just wanted to differentiate a little bit here the fact that we are doing mapping, as well as now that all the 3 sites have also started doing the ingestion process. So the mapping is something that we've been doing for some time, and there are some updates to the mapping of the previous repositories that's still being done by all of the teams that are involved here. And this is just a repeat this is just an update of all the repositories that have been mapped and by the 3 different teams. And I noticed that the DBMI team said that they're waiting for new assignments, so I think we'll go over the repository list that we do have. This is the DataMed ingestion, where the DBMI team have initiated ingesting as well. So they're now working on these. Currently, they're working on what's listed here. UT Health has completed 4 in the past week, and we are working on 4 more, and we have 5 in the pipeline. So also, just to bring to your attention that for some repositories, we are actually waiting to get some feedback from the repositories themselves. For example, SimTK seems to be having some problems with their
formatting.
Yeah, with their format, and so they said that they would get back to us in a couple of weeks' time, and if we don't hear back from them in the next 2 months or so, 2 or 3 months, we will contact them again. Similarly, UPathDB said that they would be providing web API, but they haven't sent us an update, so we've contacted them again to see where they're at. And you can see also with the CRBS team, which is Jeff's team, they're also waiting for the repositories to get back to them for multiple different reasons. So these are things that are updated. But I just wanted to also, let me just share my desktop. And I want to bring these up. So one of the things I wanted to bring up and make sure that everybody understands is this spreadsheet, which has the mapping information and also has all the information that needs to be put in here with reference to transformations. Have the transformations been checked? Is the transformation complete? has the ingestion been completed? Please enter dates here. For example, if it's SRA, which is one of the previous repositories that was already in DataMed, which is being updated. So obviously the sample data has been generated, and since it is an old repository, we don't have the dates for when the sample data was generated. So we leave this empty. But has the updated transformation been done? Needs to be checked. Has it been checked, verified against what's, you have the web checking tool, and then, so if so, then is it completed? Was the ingestion completed? Has it been updated into GitHub? Because we found out about 2 weeks ago that even though people have been doing the mapping, they don't necessarily check it into GitHub, and that's quite important for us to have it there. And then we put in the index date, and then we put in the date when it was updated into the development server, and then the final one is where it's put into the production server. So this is for all the people who are actually doing the mapping and ingestion. So all the developers that are doing it, please make sure that you update this spreadsheet with all the information that's needed. So based on this, Stephanie and I, or rather for the most part me, I'll update this spreadsheet, which has a comprehensive information for for all the things, whether it's mapped to DAX, is it updated in version 1.5 in the development server, what's the ingestion status, what's the team that's working on it, the date that we started working on it. So obviously this is not there for all the old, repositories, but you can see for the newer repositories that the date that started simply means that the date where the sample data was obtained, and then the date the metadata mapping was completed, the date that ingestion was completed, indexing is completed, and whether it's updated in development server. So for now, in production would be the release date that we have. It would be the same for up until November 22nd. But after that, whenever we are adding new repositories, we are not going to have a new release, software release. So we will just be updating at the back end, and this would be really useful for us to work on whether, to figure out whether it's gone live or not. The other thing I want to also bring to attention here is you have the ingest status, and that's completed, right? So we can look at what are the repositories that are listed here and which have not been assigned yet, and then you can start working on it. For example, if I say I don't want to have completed, don't want to have the ongoing, which means it's already been assigned to somebody, and I just say, okay, I want only those that are blank. So if you look at that, you can see that there are repositories, for example, bioproject, that's being worked on by the CRBS team, and you can see you have repositories which are being worked on the other teams. And then there are repositories down here that has not been assigned to any of the teams. So we can start working on those. So if you want to start working on that, we can assign it right now. Maybe pick about 2 or 3. So Huni, I know your team said that you're waiting for assignment of new repository. Do you want to pick some from here?
Sure. Maybe we can start with NHLBI BioLink.
Okay.
Yeah, we will start with that.
Okay. So, but this is one where you would be actually going through the complete process, right?
I see.
So you will do the complete ingestion, correct?
Mm-hmm. Yep.
So I have another question. For example, here, the Human Microbiome Project, it's been mapped,
Yes.
but I do not know if it was ingested. So if you could update, I mean, Nansu or you, if you could update this spreadsheet
Right.
along with the metadata information that you have.
Right. Yeah.
Here,
Sorry about that. Yeah. We haven't been very, I mean, we were not good at updating this spreadsheet. I'm sorry. Yeah.
That's all right.
Yeah, you
Don't worry.
should. Otherwise, we don't know what you did.
Right.
It's okay. As long as you don't need to worry about the other spreadsheet. As long as you update this spreadsheet,
Right.
I will move the information from here to the other spreadsheet. So it's really, I mean, we just didn't want this spreadsheet to be out because it just looks very complicated with a lot of information. And I don't know that everybody really wants all this information. It's useful for us to keep track of it, but I don't think it's necessary for everybody. So if you could update this with the information here, and I mean, if all the three teams can do that with the dates as well, then I will update this list here, and then each meeting we can go through what new repository can be picked up by the respective teams.
Okay.
And that was basically what I actually wanted to talk about, mainly with regard to the repositories. Now, with the DataMed version...
Anu, can I, just a question about that. I mean, number one, it's fantastic to see the spreadsheet. I mean, I wondered about the more detailed spreadsheet, and I thought, oh, wait a minute, have we got two spreadsheets here? And sure enough, we do. But it's that second spreadsheet, I think, that we're going to rely on more for the summary stuff. But clearly, we need the more at the detailed level, and it's great to see this in place. I don't know at what point we address this and how we address it, but we should bear in mind, and this still seems to be oriented around the idea of the first time, well, it's already the second time for many repositories because we're doing the DataMed, we're doing a re-import, but there's the question of how does one keep track of how you keep each repository, the information about each repository up to date, and the frequency of those updates, and how that will be managed. I mean, this still seems to be oriented around the initial activity, which involves doing a mapping, doing an ingestion, writing whatever code if it needs to be, or whichever configuration files. But after that, one assumes the updates are just going to be a more routine activity of running the same thing over again. But somehow...
Ian, that's one of the things that we have to discuss because again, there's been development on the UI side and on the ingestion side, and so all the releases, including this one, have all been around releases, like formal releases, and so that's what we have to discuss as next steps in terms of doing the more automated updates that you're talking about.
Right.
So I guess what Ian...
And I appreciate that that's the case, and I'm just reminding us that it's there and trying to get some sense of, like, when do we get to address that?
Right.
Yeah, I think what Ian, just to reinforce what Ian is saying, we often get asked, how often is it updated, or is it static? One time only, and that's it, fixed in time. So I think that's something that as you move forward beyond just working on initial release, that is mapping and ingestion, understanding and explaining how automated updating is going to be taking place on what schedule is going to be important.
Yes, we are talking about this too. So we talk about maybe have a very a well-planned scheduled release, but at the same time we also feel the need. We actually sometimes we need to update something urgently. For example, we find a bug. Last time, for example, expanding the synonyms, we want to fix it right away. So we
yeah,
yeah.
right.
So
and then, yes, of course.
yeah. So I think that there's those kind of we can have some plan to do some kind of release with defined functionalities and new data reporting, but I can expect maybe more or less we will have some kind of update to fixing back bugs which may not will be well planned for that.
So they're talking about updating of the repository information,
Right.
index. So
Yeah.
Jeff, would you be able to come up with some kind of a initial plan that we could discuss?
Yeah, I mean, because basically when on a reindex, we could easily bring data into Elasticsearch, and then flip sort of the naming, the aliases of those. And so, I mean, that's something that, again, I can, Ruling and I can, we can discuss.
Okay.
Yeah, I mean, at some point, the balance at the moment has just been counting how many repositories are we indexing and increasing that number of repositories. But I think we're getting to the point where we're going to have to balance two numbers. The number of repositories that are indexed and how often we're indexing those repositories.
Yep.
Because being able to do 100 repositories one time isn't going to convince anybody. We're now at the point where before we add more repositories, we've got to show sustainability with the ones that we have got.
Mm-hmm.
Yeah, and the reindexing, I mean, the only constraint there is basically compute power, right?
This was just meant to be a reminder not to forget that we need to address this rather than trying to delve in and solve it at this point. But
yeah, maybe we can come back to this after we are done with the release of version 1.5.
That sounds like a good idea, a good plan. That's a good point at which to turn our attention to some other things related to sustainability. And overall, this is a prototype, so among the issues associated with the prototype are things like up to date. How often is it updated? How current is the information in the repository and in the index itself?
Okay.
All right.
I think we've run out of time.
Yeah, we have to stop here because there's another meeting in this room.
So I just wanted to remind people to deposit codes in GitHub, and also if you want to look at the beta version, which is the development server, please let me know and I'll send out this link.
yes, please send it, Anu.
All right, thank you.
All right, thank you. Bye now.
Bye.
Bye.